This is our 6th grade lesson on finding the area of parallelograms, going along with benchmark 6312, calculate the area of quadrilaterals. Quadrilaterals include squares, rectangles, rhombuses, parallelograms, trapezoids, and kites. In this lesson, we are focusing on parallelograms. By the end of this lesson, I will be able to define parallelogram, find the area of squares, rectangles, and rhombuses, explain why the concept of area is important, and use square units appropriately in area problems. Our objectives are how we would begin our lesson. Now for a little bit of review. What features must a shape have in order to be classified as a square? This is relating back to our kindergarten lesson, and we will give students an option or the chance to answer this. What about a rectangle or a rhombus? We're going to focus on finding the area of shapes today, but let's discuss a little bit about what area means. Area is the amount of space inside of a shape's border. Why might someone want to know the area of something? Students would have the opportunity to offer answers about real-world area problems. We're going to be focusing on area today, but more specifically we're focusing on finding the area of parallelograms. But what is a parallelogram? A parallelogram is a quadrilateral or a four-sided shape which has opposite sides that are parallel and of equal length. Parallelograms can include squares, rectangles, and rhombuses. First, we're going to learn how to find the area of a square. The equation to find the area of a square is area equals length of base times height, or A equals B times H. Because a square has all of their sides equal, however, you can use the equation area equals one side squared. In the equation written on this slide, A equals A squared. A represents the length of one side. When writing the area of a shape, you label it with units squared, like inches squared or centimeters squared. Let's clarify square units a little bit. If a square's sides were measured in inches, the units for the shape's area would be inches squared. This works the same for all other units. 1 square inch would be represented by a square that has sides that are 1 inch long. If a square with an area of 8 inches squared, it means that 8 squares with 1 inch sides could fit into the shape. Let's practice a little bit finding the area of a square. On this slide, the instructor would solve the first problem by themselves, writing the step-by-step answer on the board, and the second problem would be solved with the students offering steps on how to solve the problem. Next, let's learn about how to find the area of a rectangle. The area of a rectangle is A equals base times height, just like with a square, except because the sides of a rectangle aren't all the same length, you can't simply square one side. You must do A equals B times H. These are more practice problems for finding the area of a rectangle. Once again, the instructor would solve the first one, showing step-by-step how to do so on the board, and the second problem would be solved with the students offering steps on how to solve it. Finally, we're going to learn how to find the area of a rhombus. Once again, like with a square and a rectangle, all you have to do is multiply the length of the base of the shape times the height of the shape. With rhombuses, however, the length of the height of the shape isn't simply one of the sides. The height of a rhombus is the vertical length from one corner to the opposite side, as shown in this image. These are more practice problems for finding the area of a rhombus. As with the other slides, the instructor would solve the first problem to show the students how to find the area of a rhombus, and the students would offer steps on how to solve the second one. Now, class, to practice finding the area of parallelograms, the students would calculate the areas of different objects around the room. Students would be broken into groups of 2 or 3, and the instructor would hand out rulers and worksheets, which will be on the following slide. The activity would be completed for 5 objects, and the instructor would make sure that objects shaped like squares, rectangles, and rhombuses were readily available throughout the room. This is an example of the practice worksheet that we would hand out to students. Students would have to identify the object chosen, the shape of the object, the formula to find the area of that shape, the length of all of the sides needed to solve the problem, their calculations, and the final area of the object with correct square units. To finish, the instructor would help Students compare their measurements to see if they had completed the problems correctly. Students would have an opportunity to ask final questions, and we would complete our closure with exit slips and hand out homework.